Welcome back, mathematicians. This time, this is going to be a part 2 for the C-level problems for 5.2. This is just the second part. Again, we're just simplifying um, radicals, okay? So I look at these numbers, I see what I can break down, and then we work from there. So for example, let's look at example 1 here. I have a 2 square root 54 minus 11 square root 6, all right? Not a problem. I start to see some things we can do with that. What I'm going to do is I'm going to break up this 54 into a 9 times 6. And you might wonder, well, why a 9 times 6? There's a few reasons. One, I already have a 6, so I'm looking for a factor with a 6. The other reason is that 9 is a perfect square, so I know I can remove it. So again, this is, okay, I'm going to go the slow way. We're going to take 3 squared times, that's a squared, times 6 minus 11 square root of 6. And again, if you're more advanced, you might skip this step. In any case, I can simplify the square root of 3. So I'm going to pull it out of my square root. That's going to give me a 3 on the outside without the square, as it came through the square root, or a prison break, whatever method you remember how to do. So again, let's simplify that now. So now let's simplify just this 2 times 3. That's going to just give me 6 square root of 6 minus 11 square root of 6. And here, again, I can treat these like x's, right? So I could factor out essentially my square root of 6's. And what I'll get is 6 minus 11 times the square root of 6. Or 5 square root of 6. Oops, negative 5 square root of 6. There you go. Not that bad. Okay, so let's look at this example now. I have a few things going on here. There's a few ways I can simplify it, but I see some solutions right away. This one we can't really simplify just yet. What we should see is I have 5 squared in here. I can't pull it out because this is a cubed root. Okay, not a problem. And then I look at this guy, 625, and I think, well, I wonder what I could pull out of there. I suspect this is a base of 5 because this one. So let's try it. 5 to the first power is going to give me 25. 5 to the second power is going to give me, oops, this is my bad. That's 25. 5 to the third power is going to give me 125. And then 5 to the fourth power is going to give me 625. Okay? So this is going to be 5 to the fourth power. Good. What I want to do now is use some of my rational exponent rules. I'm going to have 5 to the 2/3. I'm going to multiply that times 5 to the 3/4. And again, what I did was I changed these from radical form to rational exponent form. And this is why this is so useful. Now that I have the same bases, and I know I'm multiplying said bases, I can add my exponents. So I'm going to have 5 to the 2/3 plus 3 to the 4ths. Can't quite simplify that, but I can make these have common denominators. So again, if you don't remember, maybe we need a little bit more practice, but I know I should end up with 12 as my least common denominator for both of those guys. So what do I need to multiply times 3 to get 12? Well, that's a 4, so 4 times 2 is going to be 8. What times 12 gives, or 4 times 4 gives me 12? That's 3, so 3 times 3 gives me 9. And that is going to be 5 to the 17/12. Okay, and that is a perfectly acceptable answer. We can go beyond that if we wanted to. It's not a big deal. This is where mixed numbers kind of come into play, but this is a perfectly fine answer. This is going to be 5 and 1 5/12. Or, so my other answer is 5 on the outside. That's my 5 to the first power. At times 5 to the 12th root 5 to the 5th. Okay, so I mean, you could kind of tell why I'm biased towards this side, um, but either way, it works. Okay. Now that you're done with this part 2, what I want you to do is use your knowledge of what you know, try to simplify this expression,